Sup scientists, Mr. Collier here. Today we're going to get some sample data for the kilowatt lab. This right here is a kilowatt meter. You can see right now it is set to voltage and we've got about 120 volts, which is standard for American outlets. We've got where we plug devices into to see how much power they are using. Now we're going to switch it to watts for most of our usage today, so we can see how many watts things are pulling. You can also see cumulative use by looking at kilowatt hours. That'll give you how much total energy you've used. Watts is how much energy it's pulling per second right now, and that's what we're primarily going to be taking down for this lab. For each device, I'll show you the wattage when it's plugged in and not turned on, and then I'll show it again when I turn it on. So here we've got just a toaster, and it has 0 watts right now. Going to go ahead and turn it on. It's warming up. And there you can see the wattage. All right, our second device is a Keurig. This is used to make hot water. And we can see, even when it's not turned on, it is pulling some power. You're going to learn more about this vampire load in this lab. Let's go ahead and turn it on. And it switches to heating, so now it's heating up the water. You can see the amount of wattage that it pulls changes. Next we have a hair dryer. This is off, and I'm going to cycle through low, high, cool, then hot as well. So this is low and cool first. Now I'm going to do low and hot. That's your low and hot. Now I'm going to turn it on to high and cool. And finally, high and hot. Next, we're going to look at light bulbs. I actually don't have a traditional incandescent light bulb, but these are both 60-watt equivalents. So if you want to include an incandescent light bulb, you can just put 60 watts down. And then this is what they call a compact fluorescent. Here it is off. Now I've turned it on. Compact fluorescent on. And this is a 60-watt equivalent. This is an LED light bulb. There it is off. Now I've switched it on. And those wattage equivalents are because people aren't used to measuring light bulbs in actual light, which is measured in lumens, and so they're used to measuring it by the wattage that the light bulb uses. But as light bulbs get more efficient, rating them based on wattage gets a little confusing because you have to say things like 60-watt equivalent, but it's obviously not pulling 60 watts, but the light that it gives off is equivalent to a traditional 60-watt bulb. Next, we're going to look at 2 different strings of light. This is a traditional style light. There's your wattage on your traditional lights. And here is a string of LED lights. For these, we're not going to be doing any wattage while they're off because they don't turn off. You plug them in and they're on. Next, we're going to do a cell phone charger. Here it is plugged in but not charging anything. And I'm going to plug it in actually to the thing I'm recording with, which is my cell phone. Next up, we're going to do a laptop. Here it is plugged in, but not charging. Now let's plug it into charge. Next, we've got a space heater. Here it is plugged in, but not running. Now I'm going to turn it on. It's going to start heating up. Next, we have a window unit air conditioner. Here it is plugged in and not turned on. Here's the air conditioner running with the compressor on. And now let's put it into fan only mode. Next we have a microwave that's plugged in but not running. And now this is the microwave while it is actively cooking something. Next we'll do an LCD TV. Here it is plugged in and not turned on. And here's the television turned on and running. And I couldn't get behind my refrigerator, so this is a chest freezer. This is it. The compressor is not running, but it's plugged in. And here it is with the compressor cycling.